For many, linear perspective can be a difficult subject to master. Based on mathematical concepts, it can lead us away from our right brain modes of thinking. Often we may find ourselves making cold analytical drawings if the linear perspective gets in the way of our creativity. But used properly, it should reinforce our observations and will often provide solutions to some of our most daunting problems. Linear perspective can provide us with the answers. Once we learn linear perspective, we can use it or ignore it in order to express ourselves. It is only one approach to image making. And it's always important to realize that while we see things in a certain way, that doesn't mean that there isn't an equally valid other way to see things. It all depends on your point of view. In the world of the imagination, all things are possible. Yet there are certain realities that we can agree to and use to communicate clearly with each other. When we look back at the work from the Middle Ages, it can appear clumsy and awkward. This version of the Last Supper clearly tells its narrative story and has a strong awareness of the picture plane and negative shapes. But we may wonder why the food isn't falling onto people's laps. Not to mention, how will they eat with those halos blocking their faces? In comparison, Leonardo da Vinci's Last Supper shows an understanding of linear perspective. The lines of the walls recede towards a vanishing point, which brings our attention to the central figure of Christ. The mathematics or geometry of perspective actually enhance the narrative and focuses our attention. Also notice that the figure of Christ, while perfectly realistic, is also an equilateral triangle representing the Trinity. That is a true genius of the High Renaissance, mastering representation and using it to reinforce the intended messages, a convergence of science and faith. Based on observation, looking from a fixed vantage point through an imaginary plane, linear perspective was formalized by Filippo Brunelleschi. Famous for his architectural marvels like the Duomo in Florence, Italy, Brunelleschi noticed that parallel lines appeared to converge towards vanishing points. He used perspective for architecture and engineering, passing it on to his friends, artists like Masaccio, Donatello, and Masolini. These were the first to apply this knowledge to art images. So let's look at it in its simplest form. Parallel lines in the real world will appear to converge towards a vanishing point located at the horizon line. This definition also applies to two-point perspective, which is the most common use of perspective. It's used when looking at the corner of a cube or into the corner of a room. But we must be careful to make sure that our use of linear perspective reinforces what we see rather than forcing what we see to fit the system. This is a typical forced perspective drawing. Both vanishing points are forced into the picture plane, creating an extreme or exaggerated situation. When drawing from life, at least one of our vanishing points will usually be off the page, either to the right or to the left. Let's take a look at how this works. Here we are in a room, looking into the corner. That's a perfect two-point perspective situation. You can probably see how the parallel lines from each wall appear to converge, but where exactly are the vanishing points? While we will be looking into the corner of the room to draw it, let's turn for a moment and face directly towards the left wall. If we project a line from our level of vision across the room, that is our eye level or horizon line. In most cases, those will be the same thing. While still facing that left wall, consider the convergence of the lines from the right side wall. They will meet at that exact point where you are squared off and centered on the left wall. Notice that the lines of the window are parallel to the ceiling and floor line, so all of these lines converge towards the vanishing point. Now let's turn to the right, square off with that wall, and once again establish our eye level. Once again, by looking straight ahead, drilling a hole with our eyes, we have found the vanishing point for the convergence of the left wall. Notice that the right vanishing point is just off of our page. Now, imagine the viewfinder that would be needed to encompass this 90-degree shift from facing left to facing right. It would be huge. That would be a much wider expanse than we would normally consider drawing. And that is why a drawing like this looks like a forced perspective. It doesn't feel natural to include such a wide range of vision. Also, it would be unusual that the vanishing points just happen to be at the exact corners of the page, and probably not a good idea to put the horizon line right in the middle of the composition. Let's go back to the still life drawing that we did as a sighting exercise. This is a situation where there were parallel lines, and they do appear to converge. Now, if we sighted correctly, there just might be some linear perspective here. If we project those sighted lines back into deep space, beyond the edge of the drawing, we will see that they do indeed appear to be converging towards a vanishing point. The vanishing point on the right is pretty solid. The left one's just a little bit off. From these 2 points, we can establish the eye level or horizon line. Thinking back to the situation, yes, that was just about how much I was looking down at the still life. We can continue this to the other objects in the still life. Note that the cubes were not squared up with each other, so they go to different vanishing points, but they are still on the same horizon line. And this is where I notice the lines going off to the far left are not angled up towards the horizon line enough. I could have used linear perspective to correct this problem had I caught it in time. Let me go back and angle those lines upward towards the horizon line. But now, why did this happen? Perhaps I moved my head slightly to look at the left side. And those angles that are close to horizontal are tough, so I'm glad I could use linear perspective to correct my drawing. And that's how I hope you can use linear perspective to help you solve your problems. Don't let the mathematics of the system distort your drawings. Trust your instincts, but do use it to double check and correct when necessary.